So we're going to talk about some properties of light in this chapter, and the first one we'll talk about really, well, other than the ones we've talked about already, I guess, is reflection, right? We start with the law of reflection. The law of reflection states that the angle of incidence equals the angle of reflection. And so that means if I have a surface here, and I draw perpendicular to it, just an imaginary perpendicular line, a ray that's coming in at, say, this angle, right, I'll call that theta incident, will reflect at exactly the same angle. If it's reflected, some light is absorbed by a surface, but if it's reflected, then it's reflected at the angle, at the same angle it was incident at. We're always measuring the angle relative to the perpendicular to the surface, and so that's kind of a given. But for reflection, the reflected angle is the same thing as the incident angle. So there are a few types of reflection. The first one is specular reflection. It's the type of reflection you get with a mirror. So, you know, if I had a whole bunch of rays coming in parallel like this, right, they would all get reflected parallel like that, right? That's specular reflection, sort of a shininess to it, right? The other one is called diffuse reflection. It's the kind of reflection you get with clothing or paper. And so if you look at the surface of paper or clothing on sort of a microscopic level, on a level that's comparable with the wavelength of, say, visible light, right, something that's really tiny, the surface of a sheet of paper might look like this. Might look like that. And so if you had a bunch of rays, parallel rays that were coming in, you know, you might say, well, this one hits here and it goes up this way, right? And this one hits here and it goes straight back this way, maybe. And this one hits here and goes over this way. And this one hits here and goes off this way, and so on. So when the rays come in, they're bounced around in directions that aren't consistent with the direction they were coming in. And so this kind of reflection might preserve an image. It might reverse it or somehow to it by reversing the order of the rays, but this will destroy it. Right. In fact, with clothing and paper, a lot of the light is just absorbed, and so clothing that appears red under white light is absorbing all the colors but red, right? And then the red light is being reflected back out, and so the clothing appears red, but it's because the other rays were absorbed. All right, So we can ask a reflected ray question here. We can say, look, a ray is incident on, this could be some kind of specular reflector like a mirror, is incident on a mirror at an angle of 30 degrees, right? The mirror has a corner in it, and so when the mirror, when the light bounces off the mirror, where does it hit this side, right? And so we can ask the question, you know, if the light comes over and hits here, what is this distance? Right. And so, we solve this problem by saying, well, look, when it's reflected, this angle is 30 degrees, right? And that means this angle is 30 degrees because these two lines are parallel, and opposite angles for a line that cuts two parallel lines, the normal and this wall here, opposite angles are equal. And so that means this is a 60-degree angle. And that means this is a 30, 60, 90 triangle, and so this is 1, 2, square root of 3, and so d is equal to the square root of 3 times 10 centimeters, or is equal to 17.3 centimeters. If we wanted to, we could, if we didn't know that little aspect of it, we could say, well, look, tan 30 degrees is equal to 10 centimeters divided by d, or d is equal to 10 centimeters divided by tan of 30 degrees, which is 17.3 centimeters. So another property of light is that light is reversible. So a ray of light will retrace its path if it's reflected back on itself. So if I have like let me draw a couple of mirrors here. And I send a ray of light in this way, so it goes off this guy, off this guy, off that guy, right? So it does this. It goes this way, and this way. I could draw something more complicated, and then here. Well, if I just put a straight mirror here, right, then this ray will just go back this way and retrace its path. That's the principle of reversibility.